Dear students, today we are going to discuss about utility maximization under mathematical economics of 6th semester BA economics. Under utility maximization, we have to find consumer equilibrium. There are two conditions to meet. First one is marginal rate of substitution x for y, that is mu of x divided by mu of y should be equal to price of y by price of x. This is the utility maximization condition. And second condition is that indifference curves converge to the origin. That is, the slope of the indifference curves should be decreasing. So these are the two conditions for consumer equilibrium. First one is marginal rate of substitution x for y, that is mu of x by mu of y should be equal to the price of y by price of x. This is the first condition. Second condition is that indifference curves should be convex to the origin. Then we can find the consumer equilibrium. This is the picture for the consumer equilibrium where the budget line and the isocond are tangent at point E. Point E is the equilibrium, where we will get O y star of y and O x star of x. O x star of b. Okay. There are three isocones, IC1, IC2 and IC3. The budget line is only tangent to IC2. So the equilibrium comes under IC2. Then the proof for maximum utility or consumer equilibrium. Let's find the utility function, that is u is a function of x and y. Here the budget constraint is given price of x plus price of y, that is equal to m. Find the equilibrium. We have to maximize utility function subject to the price function. Utility function is u is a function of u of x and y subject to px of x plus py of y, that is equal to m. Under Lagrangian model, we have to change the constraint and equate it to 0. So the constraint has to equate into 0. So we can rewrite the constraint as m minus px of x minus pyy is equal to 0. Second step of under Lagrangian multiplier is we have to multiply the constraint function with lambda. So lambda into m minus px of x minus py of y. Step 3, that is we have to add to the objective function to form a Lagrangian function. The objective function is z is equal to u of xy. Objective function is u is equal to u of xy. Here we have to add the objective function with the constraint to form a Lagrangian function. So z is equal to u of xy plus lambda m minus px of x minus pyy. So the step 4, we have to remove the brackets. How we remove the brackets? Multiply with the lambda. So the function will be z is equal to u of xy plus lambda m minus px of x minus py of y. So we are removing the brackets in the constraint, multiply lambda with all these variables lambda m minus lambda px of x minus lambda py of y. So we can find the partial differentiation, that is dou z by dou x is equal to dou u by dou x lambda px, that is equal to 0. In the second one, we are finding that partial differentiation of the function z with respect to y. So that is dou u by dou y, that is equal to minus lambda py. In the earlier function we get dou z by dou x. That is, we are finding the differentiation with respect to x. We are finding the differentiation of the function z with respect to x. That is dou u by dou x. So we will get minus lambda px is equal to 0. Then step 5, that is divide the equation 1 by equation 2. Equation 1, that is dou u by dou x by dou u by dou y. So we will get marginal utility of x by marginal utility of y, that is mrs xy, that is equal to px by py. This is the proof for the function. Then let's find a problem. A consumer using two goods Q1 and Q2 has a utility function U is equal to Q1 Q2. Price of the first good is 1 and price of the second good P2 is rupees 4. The consumer has total income 120, that is the total budget is 120 on two goods. Find the quantities of two goods the consumer should purchase on maximum utility. Find the utility maximizing level of consumption for utility function, that is Q1 plus 4Q2 is equal to 120. This is the utility maximizing level of consumption utility function. Second is objective function. Objective function is given U is equal to Q1 Q2. Set the budget constraint, that is Q1 plus 4Q2 is equal to 120. Equate the constraints to 0, that is Q1 plus 4Q2 is equal to 120. We are equating this equation to 0, that is 120 minus Q1 minus 4Q2 is equal to 0. Then step 3, we are multiplying this equation with lambda. Then adding to the objective function. What is the objective function? Q1 Q2. U is equal to Q1 Q2 plus lambda 120 minus Q1 minus 4Q2. Then removing the brackets and multiplying this objective constraint with the lambda. So the equation will be U is equal to Q1 Q2 plus lambda 120 minus lambda Q1 minus lambda 4Q2. Then in the fifth step, we are finding the three partial derivatives, set them equal to 0 and solve the values for Q1 and Q2. So equation is U is equal to Q1 Q2 plus lambda 120 minus lambda Q1 minus lambda 4Q2. First we have to find the differentiation of U function with respect to Q1, that is equal to Q1. So Q1 Q2, here Q2 minus Q2. So here is minus lambda. We are finding the differentiation of u function with respect to q1. So q2 minus lambda is equal to 0. That is q2 is equal to lambda. Then second one, dou u by dou q2. That is, we are finding the differentiation of u function with respect to q2. That is q1 minus 4 lambda. That is equal to 0. So q1 is equal to 4 lambda. Then find the differentiation of u function with respect to lambda. That is 120 minus q1 minus 4q2 is equal to 0. That is 120 minus 4 lambda minus 4 lambda is equal to 0. So rearranging, we will get 120 minus 8 lambda is equal to 0. So lambda is equal to 120 divided by 8, that is 15. So we got the values for q1, q2 and lambda. Lambda, the value is 15, q2 the value is 15, q1 the value is 5. So the answer for equilibrium level of output 15, that is the total utility is 60. Okay, thank you.